Welcome all for the video tutorial on machine learning, and today we are seeing about the fourth module, which is Bayesian learning, and we'll discuss the sixth topic of our fourth module, which is naive Bayes classifier. First we'll see what is classifier. Okay, classifier is nothing but we use this term for the classification purpose. One of the main applications that we use in machine learning is classification. Okay, there is need of classifying the data so that you could construct a model, and that model will be capable of classifying your data. Okay, and we classify the data under a label. Okay, we use a term label for classifying or grouping a data. For example, a grocery, when a grocery list of grocery is given, and that is my input, and now I have to classify that into various categories. So I group all my vegetables under the label vegetable. I group all my fruits under the label fruits, and all the spicy item under the label spicy. Okay, this is how I classify the data. So most of our application needs the classification of data. Okay, and how do we do is we classify the data, and that classification is based on the training set. It is based on the training sets and the values in the classifying attributes, and it is using the, and it is this is how it is classifying. We will be classifying the data based on the attribute. So when you give an input, the input process certain features, and based on these features, by analyzing these features, how this features are analyzed by the training set. You would have already trained those features, those sets in the database, and now based on that training set it is going to classify. Okay, when you give an input, that input will be given to the prediction next layer, and there it is going to compare the given data with the already trained set of data, and with that trained data set, with the knowledge of that, the knowledge of the machine which has already been learned by the given set of data, now it is going to help you to classify the data under certain labels. Okay, and a typical example that we use, where we use classifier in day-to-day life, is credit approval, target marketing, medical diagnosis, and treatment effectiveness analysis. See, what about credit approval? So we have an scenario for sanctioning the credit. Okay, so we have to, when an input is given, it has to be analyzed whether it comes under that category. Okay, whether it comes under the scenario where you can approve the credit. So you are going to classify the data over there. In target marketing, so the marketing, when the marketing is done to all the people, then there is waste of time, and you will not get the productivity as expected. Instead of marketing the entire people, when you focus on target marketing alone, that is when you focus on the people who will prefer this product, then it will be giving you the enhanced productivity. So there what we do, even there we are classifying the data. So we are classifying the peoples so that we could identify who are the target people, so that the marketing can be done effectively. Then medical diagnosis, so we will be classifying the data. So when data is given, for example, the cancer prediction, when the when the cells are given, your model has to classify between the input, that is between the normal cells and the tumor cells. Okay, so even there we are using the classifier application. So it is application of classifier. Then treatment effectiveness analysis. See, what is the measure of the particular disease and how it has to be treated. That is also, we will be grouping that under the classification. And this is actually done by two-step process. First is model construction, and next is model usage. Okay, for classifier, to build a classifier, we have two-step process. The first step involves the construction of a model. The second step is the model usage. In the construction of model, you will be describing all the predetermined classes. What are all the classes that attributes can have, and you will be defining all those classes. Okay, and you will be training according, based on that classes. Based on that classes, you will be training your data set. and this model you will be represented by a classification rules, decision tree, or any mathematical formula can be used for implementing this. The next step is your model usage, and we use this for classifying our future or unknown data. Actually, the model construction, you go with the data which has been already trained, that is known data. But model usage, here you will be working under the, it has to classify the data which is unknown, okay, which is unknown. So that may occur when you give an input, okay, but you would have not trained that. But instance, if you get an object or if you get an input which has not been trained, even then your system should be capable of classifying that data under a certain label. Now we'll see what is Bayesian classification. So far we have seen what is classification and what is the term classifier is. Now we will see what is Bayesian classification. Okay, this is a statistical method for classification, and this comes under supervised learning method. And we have an underlying probabilistic model here, and with that model we are going to implement a Bayes theorem. Okay, in the classification we implement the concept of Bayes theorem for performing the classification, and this can be used for solving it can be used for solving the problems which is involving both categorical and continuous valued attributes. And this was found by the Thomas Bayes, and he is the person who has proposed this algorithm. So we will see an example for a Bayesian classification. See here, now we are going to classify a data, okay, and how do we implement the Bayesian algorithm for this classification, we will see. Here what is the data? The data is that we have to classify the people. We have a people, and we are supposed to classify the people who are supposed to buy a computer. Okay, now how do I classify the data? I have the numerical data for the strength of the people. Now what I do is I group the people into different cadres. Okay, so who will use first? Will based on the application we will use the, here we are saying we are categorizing the people into the cadre of age. Okay, the label what we group is age. So why do we go for that? See, the age is also an important factor to determine this scenario. Okay, your baby, the people who's under 5 years may not use, or 10 years may not, there will be the usage of your mobile phones will be less, or the aged people who's above 60 years, the usage of Android mobile phones will be, or usage of computer will be less. So for that we are categorizing the data first. So under the label of age we are going to categorize. Okay, this is one of the important feature which is determining the criteria for buying an computer. Next feature, when you take, okay, we will be checking about their income. Okay, what is their actual income they are earning per month. So because the people who are not who's capable of buying a computer should have an at least income, so that he can go for it. So we are categorizing that. So the students who are the people who are at age 14, they will not have an income to buy a computer, or the aged people, again this comes into the role. Okay, now again in that classified label with the age, we categorize the data into based on the income. Okay, and this how do we pick out the people based on the income? We apply the Bayes theorem here. See, we apply a Bayes theorem, and that is given by the formula V map. Okay, and f, that V is nothing but for f functions. Okay, for the target function f, x or the attributes. Okay, and in attributes, what is the function of a certain feature to occur. Okay, the V map, maximum posterior hypothesis. We are going to determine the maximum posterior hypothesis first. Okay, with that formula, what is the formula we are using for maximum posterior hypothesis? We are using argmax of Vj to the belonging to the capital V, the probability of Vj. Vj is a particular instant what is happening. So here what is the particular instant? We will choose the income. So Vj is the particular attribute of the given data sets, given attribute. So A1, A2 up to An is the attributes. Among that we are going to categorize the people who is having the a particular income, range of income, that we define it as Vj. Then we derive that using the formula. We apply the probability formula there, and we apply argmax Vj belongs to the capital V, the probability of A1, A2 up to AN, given the condition Vj. Now we are going to find out the attributes who is having the particular scenario Vj. What is the Vj condition here? Vj is the people who is having the certain range of income are multiplied with the probability of the again the income. So when you calculate that, you will be able to determine the V map. This is how you implement the Bayes theorem in the naive Bayes classification. We are applying Bayes concept to classify a data under certain label. This is all about the introduction of naive Bayes classifier. Thank you all.